Hello everyone, my name's Hamza Itani. I'm an A-level further maths student, and generally my whole life I've been good with numbers. Recently at a lecture at Greenwich University, I was introduced to the concept of the future of mathematics. Now maths, I was told, is more than just numbers. It's algorithms and theorems too. Let me explain. Let's take your TV as an example. Now, your TV uses satellites in space in order to get a signal, and you can watch your TV. Happy days. Now, you may think the satellite was developed just by science and space technology. However, although science does link into maths, a large portion of this would have actually been vigorous mathematics in order to calculate the velocity needed for this satellite to orbit our planet. And whilst on the topic, did you know that the brain behind the show The Simpsons is mainly made of mathematicians? You wouldn't expect that at all. You see, there's two branches of maths. There's pure maths and applied maths. Pure mathematics is essentially maths for the fun of it. It's just doing it for the love. This kind of maths allows you to create questions and answer them yourself, and although they have no use whatsoever, it's just a challenge for us. For example, we still don't know why prime numbers occur as they do. It seems random. Now, this type of maths stems a lot of creativity, hence why a load of these mathematicians have gone and joined the Simpsons cast. Now, obviously, if we're going to talk into the future, we're not going to need pure mathematics. We're going to need applied. With applied mathematics, there's an example I'd like to share with you which relates to practically all of us, the London Tube and Tram system. The London Tube and train system, rather. Not many people clearly use trams. Does anyone here actually use trams? A one? Yeah. So if we look at the London Tube and train system, we're going to notice the fact that, well, obviously there's delays, but they're handled very well in a short space of time. This is going to be due to a computer system. You could probably guess that. But how does this computer system do it? Through a branch of mathematics called decision mathematics, we're able to tell the computer software what to do in what situation, and essentially automate loads of different ways in order to make the tube and train system more efficient. Now, this is just applying to our current day lives. Let's take maths into the future. If we want to look into the future, I suggest we look into the Claygate Maths Institute. This institution labels 7 mathematic questions every decade or so and gives them each a prize of $1 million. It's quite a lot of money for a simple maths question, except it's not that simple. In fact, most of them are more complex than what I can actually explain myself, but one which we could all grasp would be the Navier-Stokes equation. Now, all it is to define how fluids move due to their properties mathematically. You may wonder, what use is this? Well, let's say you're a doctor. You want to see if someone is ill, however, they may have an allergic reaction to needles, something strange like that, or just because the patient doesn't like needles. How would we go about this? You see, with this mathematical equation, we'd be able to analyze blood without actually extracting it. Further on, oil industries would be able to benefit from this one simple equation. You see, instead of creating pipes for oil to be carried through and running through multiple prototypes, a simple mathematical equation could give you an ideal property of any material, and you just pick a material that nearly fits those properties. Now, mathematics, as I did say, is more than just numbers. You see, maths has fallen into place over the past few centuries. It's not been planned, however, it's affected our future. And as Einstein did once say, I do not think into the future as it all comes into place. Thank you.